welcome to Better's channel, a channel whereby basic foundation in mathematics and physics will be explained to you in each context. So from what we have here, if you are new on this channel, kindly please subscribe so that YouTube will notify you whenever a new video is being dropped on this channel. So today we'll be dealing with measurement and each unit. But before we move on to that, let me quickly remind you the definition for physics. Physics can be defined as the scientific study of matter and energy and how these two things interact together. Remember that matter is defined as anything that has a mass and at the same time can occupy space. In a little world of physics, we can say that everything on earth are made up of matter. So from there we have energy. Energy is the ability or the capacity to do work. That is to say, no work can be done without the use of what? Energy. So from today we'll be moving down to what we call measurement and each unit. But focusing on this word unit on its own, it has been earlier stated that no quantity in physics can be accepted except it can be measured and given an SI unit for that. So we said the word SI unit means international system. International system of units. And in another short form of it, we can at the same time call it system international. So from here we'll be dealing with quantities in physics, and these quantities we have what we call the fundamental quantities, the derived quantities, what we call the physical quantities, in which those are segmented under dimensions. We have what we call the scalar and the vector quantity. In the second part of this video, we'll be dealing with derived quantities, scalar and vector quantities as on it too. So for this, we have what we call the fundamental quantity. The fundamental quantity. So we say fundamental quantity are those quantities that are independent of every other quantity. In a single way, we can just say that these quantities are capable of standing on their own. They don't depend on any other quantity. An example of such, we have a table given from what we have. We have a table from here. We have this first part of it, we call it fundamental quantity. We have the other part of it, we call it unit. And we have the last part of it, which we call the unit abbreviation. The unit abbreviation. So let me make use of this part of the board to explain to you what fundamental quantity, definition for fundamental quantity. Remember, as earlier stated, that fundamental quantity are those quantities that are independent of every other quantity. And remember, in another way, we can say they can stand on their own. Full stop. So fundamental quantity are those quantities that are independent of every other quantities. In another way, we can say they are quantities that they can stand on their own. And remember, this segment of it, we call it SI unit, in short abbreviation. But the full meaning of SI unit is what we call the international system. The international system of units, or system international. So from what we have there, so now from what we have on the board, we are going to start this. We say fundamental quantities are those quantities that are independent of every other quantities, and these are quantities that can stand on their own. Now we are going to be looking forward into examples of fundamental quantities those quantities that are capable of standing on their own. And we have the first segment we call, the first one we have on our list is what we call the length. And you should never be surprised that length is defined as the extent of space between two objects. Length is defined as the extent of space or distance extended between two objects. So SI unit for length is what we call the meter. The SI unit for length everywhere is what we call the meter, and the unit abbreviation always occur with the first letter, and here is going to be what we call the M. So we'll move to the next second part of it, which we call the mass. The mass. Remember that mass, as earlier has been stated, that mass is commonly defined as the quantity of matter. That is to say, every particles that are made up of matter has a mass, including we human beings as our own self. So the SI unit of mass is what we call the kilogram, and the unit abbreviation is what we call the kg. So we have the third one as what we call time. Remember that time is the duration of an event. That is to say, for every event to take place, time is being required. And he said time is the duration of an event. No event can take place without the use of time. So we have the SI unit of time as what we call the seconds. Unit abbreviation for time occurs with the first letter X. So we have the fourth one, which we call temperature. The SI unit for temperature is what we call the Kelvin, and unit abbreviation occur with the first letter K. So, and at the same time, you should never forget that temperature is defined as a degree of hotness or the coldness of a body or an object. So from there we have the fifth one, which we call electric current. And the unit abbreviation for electric current is what we call the ampere, and unit abbreviation is what we call the A. We have the sixth one we call amount of substance. SI unit for amount of substance is what we call the mole, and the unit abbreviation is still the same thing as mole. We have the seventh one, the luminous intensity. And the SI unit for luminous intensity is what we call the candela. Unit abbreviation CD. So on this first segment of it, remember that we are still dealing with the fundamental quantity, and we said that fundamental quantity are those quantities that are capable or that are independent of every other quantity. And we said that no quantity in physics can be accepted except it can be measured and given a unit. So SI unit means the system international or the international system of units. And from what we have here on this term, this is what we have as the 7 examples of fundamental quantity. So thank you.